Hello everyone. So the topic of discussion for today is diodes and how do we solve circuits that involve more than one diodes. So in any circuit that involves more than one diodes like here, we must assume the current state of operation of the diodes and then solve the problem and then realize whether the assumption that we made is correct or not and either do the iteration once again, or if the assumption is correct then that will be the final operating point of the circuit. So since we have two diodes, there are four possible regions of operations for these two diodes. When both of them are on, when only D1 is on, when only D2 is on, when only D2 is on and D1 is off, and when both of them are off. So let's say we say that D2 is off. So this is an open circuit because the diode is off and we are given that the diodes are ideal. So if this is an open circuit, there is no current to the resistor because there is no current path. Hence this current is 0. So this potential will be same as this potential since there is no IR drop across the resistor. So this will be 10 volts. Now since the positive terminal of the diode is at 10 volts for D2, this diode will most likely conduct because 10 volts is the highest rail in the circuit and this is a very high potential. So this delta V across the diode will be greater than 0. So the assumption that we made is not correct for D2 being not conducting. So D2 will conduct since this P junction is at a higher potential than this junction because this cannot be higher than 10 since the rail of the circuit is at 10. So D2 will conduct. So we can rule out these two possibilities where D2 is off. Now we have only two possibilities based on the region of operation of D1. So let us assume that D1 is off for time being. Then since D1 is on and D1 is D2 is on, D1 is off, the equivalent circuit that we have is something like this. This is 5 kilo ohms and this is 10 kilo ohms. And we wish to find out the potential at B so as we can decide whether D1 is actually conducting or not conducting. So let's say this potential is X. So we have two methods to calculate the value of X. First is superposition. So when we use superposition, we can ground this node. This was 5 kilo ohms, this was 10 volts, and this was 10 kilo ohms. So this will be 10 by voltage division. This will be 10 into 5 by 15. And when we ground the 10 volt rail, we will have the equivalent circuit like this. And this potential will be, since this is minus 10 volts, this will be again by voltage division minus 10 into 10 by 15. So when you sum these two potentials by the theorem of superposition, we'll get the value as the sum of these, which will be 50 by 15, negative 50 by 15, that will be minus 3.33 volts. The other method is that you take the equivalent series resistance as 15 kilo ohms, take the equivalent battery voltage as the difference between these two terminals as 20 volts, and give the current as 20 by 15 milliamperes, and then you have the drop across the 5 kilo ohm resistor as 20 by 15 milliamperes times 5 ohms. So the drop comes out to be 20 by 3, which is 6.66 volts, and since this is minus 10, this will be minus 3.33 volts. So now since we know the potential at this node being minus 3.33, the negative potential is lower than the positive potential, and this is 3.33 volts, which means that D1 is forward biased. So the assumption that D1 is not conducting is not correct, and we got to know that both D2 as well as D1 are conducting. So now we can solve the circuit knowing that these two diodes conduct. So since these two diodes are conducting, both of them can be replaced by short circuits. Since this node is at ground, the potential at node B will be ground, and since D2 is also short, the required voltage that is being asked in the question is also 0. So the first answer is 0. Next, we wish to calculate the values of the current I and ID2. So ID2 will be just the difference between this, since V is 0. So this voltage across the resistor will be 10 volts and ID2 will be 1 milliampere. Since this is 0 and this is minus 10 volts, the current will flow from higher potential to lower potential, which will be 10 by 5 kilo ohms, which will be 2 milliamperes. And in order to satisfy KCL at this node, since this current is 1 milliampere, this current is 2 milliamperes, the current that is coming from the ground is 1 milliampere. So we have calculated I to be 1 milliamperes and ID2 also to be 1 milliamperes. That will be the answer to the problem. Thank you.